Hey, it's Miss M, and today we're going to learn about how to simplify roots and radicals. So you're probably familiar with the term square root, and a square root is a symbol that looks like this, okay? It can also be called a radical. They're the same word they're the different words for the same thing. So our first example we're going to look at is the square root of 120. Now, what we're trying to do today is we're trying to simplify this, okay? Now, simplifying does not mean grabbing your calculator and typing in the square root of 120, hitting equal, and then saying, oh, okay, it's 10.9544515. That is not a simplified answer. What that is an approximation of the value of the square root of 120. But in math, we don't want to use approximations. We want to use exact numbers. Just kind of like in fractions, how we take a fraction and we just simplify it down to its most simplified form, but then we leave it in fraction form. Same here. We're going to get this simplified to its most simplified form, and then we're going to leave it in a radical form. Now, let's take a look at how to do this. In order to do this, we want to make something called a prime tree. And a prime tree is where we take a number and we figure out what prime numbers are multiplied together to give us that number. So for 120, I know that 120 ends in 0, and any number that ends in 0 has to be divisible by 10. So if I take 120 and divide it by 10, I get 12 times 10. So I have 12 and I have 10. Now, neither one of these is a prime number, so I need to keep going. 12 can be divided into 3 and 4. It can also be divided into 2 and 6. Either way, you're going to wind up with the same thing. That's what's kind of cool about prime trees. You can follow whatever path you want on a prime tree. You're always going to get the same answer at the end because this number is made up of a certain product of primes. Now, 3 is a prime number. Whenever I get to my prime numbers, I want to circle them. 4 is 2 times 2. Those are both prime numbers, so I'm going to circle them. Now over here, 10, 2 times 5, those are both prime numbers as well. So I'm now done. I've got every single line of the tree to end in a prime number. My next step, I'm going to go back over here, write my radical or my root symbol, and I'm going to write these numbers, these prime numbers, in order multiplied by each other. This is called the product of primes. So here I have 2 times 2 times 2 times 3 times 5. So what I have is the product of primes inside of my radical or inside of my root. Next step, I'm going to circle pairs of numbers. Here I have a pair of 2s, so I'm going to circle those. Then my rest of my numbers are 2, 3, and 5. I don't have any pairs there, so I can't circle anything. Now, the thing to understand about roots or about radicals is that they're leftover numbers. They're numbers that are left over that basically couldn't be divided by something or couldn't be rooted. So what do we do with leftovers? Well, if you have leftovers after dinner and you don't want to eat them right then, you put them in the fridge. Or let's say you don't like leftovers, well, then you put your leftovers in the compost or in the trash. No matter what you do with leftovers, you put them in something. And so in a square root or in any sort of root, because there are cube roots and other types of roots. So in a root or in a radical, our leftovers go in the root. So 2, 3, and 5 are leftovers. They're going to stay in the root. So we've got 2, 3, 5. Now, what about this pair of 2s that we had here? Well, what this is it's 2 times 2, and 2 times 2 is 4. But it's inside of this root symbol, and so we would take the root of it, and the root of 4 is 2. So we would write a 2 here. But an easier way to remember that is anytime you have a pair of numbers, you're going to pull one of those pairs out, one of those numbers out, side of the radical. Okay, so that goes out. Now, anytime we don't have a math operation symbol in here between something, that means they're being multiplied. So this is 2 times the root of 2 times 3 times 5. But we're not quite done yet. We can't leave this as 2 times 3 times 5. We have to actually multiply that out, and we get 2 root 30. And that is the simplified version of root 120, okay? Not that decimal that if you put it in your calculator, but this. This is an exact number. Let's take a look at a couple more examples. The next example I want to look at is 4 root 48, or 4 radical 48. So in this case, we already have a number outside of the root. We're just going to leave that for a little bit until the end. The number inside of the root gets a prime tree. So we've got 48, and we've got to do a prime tree. I'm going to do 4 and 12. 4, 12. 4 is 2 times 2, and 2 we know is a prime number. 12, I'm going to do 3 times 4. 3 is a prime number, and 4 is 2 times 2. So I've got all my prime numbers now. Next step, write them out in order inside of the radical. Now this 4, that has to come down as well. So 4 radical 2 times 2 times 2 times 2 times 3. Okay, 2 times 2 times 2 times 2 times 3. Product of primes. Next step, circle our pairs. There's 2 2s. Here's another 2 2s. So these are going to come out, and remember, leftovers stay in. So how I write this is 4 times 2 times 2. Leave the leftovers in the root 3. Okay, but just like before up here, where we had to multiply these out to get my proper answer at the end, 2 times root 30, I've got to do the same thing down here. I've got to multiply these together. So 2 times 2 is 4, times 4 is 16. So my answer is 16 root 3. And that is the simplified form of 4 root 48. Now let's take a look at an example that has a variable in it, just to show you that it's the same type of concept. We're going to do root 72 x squared. Okay, so root 72 x squared. First step is we've got to make our prime tree. Now we're not going to make a prime tree of x because it's not a number. I'll show you in a little bit what we do with that. But 72, I'm going to do 8 times 9. Here's 8, here's 9. 8 is 2 times 4. 2 is a prime number. 4 is 2 times 2. So that is going to be my prime numbers on that side. Now over here, I've got 9, which is 3 times 3. Okay, so I've got my primes. Now the x, I know that x squared is the same thing as x times x, because remember, with an exponent, that's just telling you how many times you multiply that base by itself. The base is x, so I multiply that x times itself 2 times. So what I'm going to write now inside of my radical, my product of primes is 2 times 2 times 2 times 3 times 3 times x times x. Okay? And this is a prime example of why we don't like to use the little x symbols as multiplying anymore in math, and instead we use the dot. Because if you were still using the x's for multiply, this would look very confusing. Okay, next step. Circle our pairs. Here's a pair of 2s. Here's a pair of 3s. Here's a pair of x's. Remember, when you circle a pair, one of the numbers comes out, bloop, 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 and the leftover stays in. So what this becomes is 2 times 3 times x. See, I just took those from those pairs, 2, 3x, root 2. Okay, but I'm not quite done because I need to multiply these together. So I will get 6x root 2. Okay, and that's it. That is the simplified form of the root of 72 x squared. All right, couple more examples. Next, the root of 144. Now, if you remember your times tables really well, you'll remember that 144 is 12 squared. okay? 12 times 12 is 144. But let's say that you don't remember that, and so you go ahead and solve this the long way. That's totally fine. You're going to get the same answer, and let's take a look at that. So 144. Okay. Now let's say that we're kind of struggling on what to see this broken into, but you remember that it's an even number, and if it's an even number, it has to be divisible by 2. So I'm going to take a 2 there, and here I'm going to get 72. 72 I can also divide by 2, which is going to give me 36. 36 divided by 2 is 18. 18 divided by 2 is 9, and that's going to give me 3 and 3. So in general, it's not a great idea to divide by 2 if there's a bigger number you can divide by, because you see how kind of like long this prime tree is, but it's not a big deal. It's just not as beautiful to look at. So there's a prime, 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 prime. Now I write my products of primes. 1, 2, 3, 4 2s, 2 times 2 times 2 times 2, and 2 3s. Okay, now it's time to circle my pairs. Here we go, there we go, there we go. So you'll notice I don't have any leftovers left inside the radical. So the radical goes away, there's nothing left inside of it. These all come out, 2 times 2 times 3. 2 times 2 is 4, times 3 is 12. So the answer is 12. So it doesn't matter that you forgot that the root of 144 was 12. You still got the answer. And in fact, you got the answer in a way that proves that the square root of 144 is 12. So that's an approach for this one. Now we have 2 more types of examples to take a look at. Let's say you have the root of 16 over 9. Now, I know the first instinct here might be to panic because there's a fraction, and I don't know why, but whenever we see fractions, there's tends to be a little bit of panic. But you just have to remember that this is the same exact thing we've been doing, okay? And you can actually split this up. So the root of 16 over 9 is the same thing as the root of 16 over the root of 9. They're the same thing. And now we just proceed like we would anyway. Well, I know that the square root of 16 is 4. And I know that the square root of 9 is 3. So there's my answer, 4 over 3. And remember, fractions, we leave them in the most simplified form of fraction. I don't divide this into a decimal. That would be not a good idea. You just leave it as a fraction. But what if you have a fraction that isn't as easily rooted? Like maybe you have the root of 50 over 9. Well, in this case, remember, first step, split your roots. 50, 9, okay? And now what I'm going to do, this number, I can't easily find the root of, but this one I can. So I'm going to have on the bottom 3. On the top, I need to make a prime tree. 50 is going to be, well, I see that 0 there, so I know it's divisible by 10. It's 5 and 10. 5 is a prime number, so I'm good there. 10, that's going to be 2 and 5. So if I write out my product of primes, I get 2 times 5 times 5. Circle my pairs, 1 comes out. That's going to give me 5 root 2 over 3. And that is my answer. And then you just leave it. You're done. It's simplified. Okay, next, last example. What if you have something like this? The root of 30. Okay, same thing we've been doing. Let's make a prime tree. 30, it's divided by 10. So in 3 and 10, 3 is a prime number. Here I get 2 and 5. So now I write my product of primes. 2 times 3 times 5. Notice I always write them in numerical order, smallest to biggest. 2 times 3 times 5. Now here, I don't have any pairs of numbers. That means nothing can come out of this radical. It's going to stay like this. But we know that anytime we have numbers inside the radical or out, anytime we have things multiplied by each other, we've got to just go ahead and do that. So we're going to get 2 times 3 is 6. 6 times 5 is 30. So the simplified form of root 30 is root 30. Okay, it's already the most simplified it can be. But if you see a problem like that, you can't just write done or most simplified. You need to show the evidence that it is that simplified, okay? And that's why we do the prime tree and then show the product of primes. So that's all I have for today. If you have any questions, let me know and I'll see you guys another day.